According to the National Electrical Code, specifically NEC Section 501.10b2, flexible cords shall not be used in Class 1, Division 1 locations, except as permitted in 501.110b or where specifically permitted elsewhere in this code. Exception 501.110b permits the use of flexible cords in Class 1, Division 1 locations only for pendants, fixture whips and control cables. Mixing motors are not covered by any of these exceptions, therefore, flexible cord cannot be used to connect it to the explosion-proof junction box. In a Class 1 Division 1 location, all wiring must be installed in a manner that prevents the ignition of flammable vapors. This typically requires the use of rigid conduit, explosion-proof fittings, and other approved methods. It is critical to understand the implications of using incorrect wiring methods in hazardous locations. The National Electrical Code, or NEC, provides specific guidelines to ensure safety and prevent explosions or fires in environments where flammable gases, vapors, or dust are present. When a room or area is classified as Class 1 Division 1, it signifies a high risk of explosion or fire due to the continuous, intermittent, or periodic presence of flammable materials in the air under normal operating conditions. The NEC defines Class 1 locations as those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 further specifies that these flammable materials are present under normal operating conditions, frequently present because of repair or maintenance operations or leakage, or might be present because of equipment breakdown or faulty operation. Given the inherent danger in Class 1 Division 1 locations, strict adherence to the NEC is essential. The primary objective is to prevent any electrical equipment from becoming an ignition source. This means that all electrical components, including wiring, must be designed and installed to contain any potential sparks or explosions within an enclosure, preventing them from escaping and igniting the surrounding atmosphere. The NEC mandates the use of explosion-proof equipment in Class 1 Division 1 locations. Explosion-proof equipment is designed to withstand an internal explosion of a specified flammable gas or vapor and prevent the ignition of the surrounding atmosphere. This is achieved through robust construction, tight seals, and specialized fittings that contain any internal explosion and cool the escaping gases below the ignition temperature of the surrounding flammable mixture. The prohibition of flexible cords in Class 1 Division 1 locations is a key safety measure. Flexible cords are not designed to contain explosions or prevent the escape of sparks. Their construction typically involves stranded conductors insulated with flexible materials, which are not as robust or tightly sealed as rigid conduit systems. If a fault were to occur within a flexible cord in a Class 1 Division 1 location, the resulting spark or explosion could easily ignite the surrounding flammable atmosphere, leading to a catastrophic event. Instead of flexible cords, the NEC requires the use of rigid conduit in Class 1 Division 1 locations. Rigid conduit, typically made of steel or aluminum, provides a robust and continuous enclosure for electrical conductors. It is designed to withstand significant mechanical stress and provide a barrier against the ingress of flammable materials. When properly installed with explosion-proof fittings, rigid conduit forms a complete explosion-proof wiring system that can contain any internal explosion and prevent the ignition of the surrounding atmosphere. Explosion-proof fittings are specialized components used to connect sections of rigid conduit and to connect conduit to explosion-proof enclosures such as junction boxes and motor housings. These fittings are designed with threaded connections and tight seals to ensure a continuous explosion-proof pathway. They are also designed to cool any escaping gases below the ignition temperature of the surrounding flammable mixture. The installation of rigid conduit and explosion-proof fittings requires specialized training and expertise. It is essential to follow the manufacturer's instructions and the NEC guidelines carefully to ensure that the system is properly installed and that it will function as intended in the event of a fault. In addition to rigid conduit and explosion-proof fittings, other approved wiring methods may be permitted in Class 1 Division 1 locations depending on the specific application and the approval of the authority having jurisdiction, also known as the AHJ. These alternative methods must provide an equivalent level of safety and be designed to prevent the ignition of flammable materials. When wiring a mixing motor in a Class 1 Division 1 location, it is crucial to ensure that the motor itself is also rated for use in such hazardous environments. Explosion-proof motors are specifically designed to contain any internal explosion and prevent the ignition of the surrounding atmosphere. They are constructed with robust housings, tight seals, and specialized cooling systems to ensure safe operation in hazardous locations. The mixing motor should be directly connected to the explosion-proof junction box using rigid conduit and explosion-proof fittings. The junction box serves as a central point for terminating and splicing the electrical conductors. It should be located outside the Class 1 Division 1 area, if possible, to minimize the risk of exposure to flammable materials. If the junction box must be located within the Class 1 Division 1 area, it must be an explosion-proof enclosure. The wiring within the junction box must also be done in accordance with the NEC guidelines for Class 1 Division 1 locations. This includes the use of approved splicing methods and the proper grounding and bonding of all electrical components. Regular inspections and maintenance of the electrical system in a Class 1 Division 1 location are essential to ensure continued safety. Inspections should be conducted by qualified personnel who are familiar with the NEC guidelines and the specific requirements for hazardous locations. Maintenance should include the periodic tightening of connections, the replacement of damaged or worn components, and the testing of the grounding and bonding system. Any modifications or repairs to the electrical system should be done in accordance with the NEC guidelines and with the approval of the AHA. It is also important to train personnel who work in or around Class 1 Division 1 locations on the hazards of flammable materials and the proper procedures for working safely in such environments. Training should include instruction on the use of personal protective equipment, the proper operation of electrical equipment, and the procedures for reporting and responding to emergencies. In summary, the use of flexible cords in Class 1 Division 1 locations is strictly prohibited by the NEC due to the high risk of explosion or fire. Wiring for mixing motors and other electrical equipment in these locations must be done using rigid conduit, explosion-proof fittings, and other approved methods. Adherence to the NEC guidelines, proper installation practices, regular inspections, and thorough training are essential to ensure the safety of personnel and property in hazardous locations. Always consult with a qualified electrical engineer or contractor to ensure that the electrical system meets the NEC requirements and is safe for use in the specific hazardous environment. The consequences of using flexible cords in Class 1 Division 1 locations can be severe, including explosions, fires, injuries, and fatalities. It is therefore imperative to follow the NEC guidelines and prioritize safety in all electrical work in hazardous locations. Furthermore, it is essential to stay updated on the latest revisions and interpretations of the NEC. The NEC is updated every 3 years to reflect changes in technology, industry practices, and safety standards. Staying informed about these updates ensures that the electrical system is always in compliance with the latest requirements and that the highest level of safety is maintained. In addition to the NEC, other codes and standards may also apply to electrical installations in Class 1 Division 1 locations. These may include local building codes, fire codes, and industry-specific standards. It is important to be aware of all applicable codes and standards and to ensure that the electrical system complies with all requirements. The authority having jurisdiction, OJ, plays a critical role in ensuring the safety of electrical installations in Class 1 Division 1 locations. The AHA is responsible for enforcing the NEC and other applicable codes and standards. They review plans, conduct inspections, and issue permits to ensure that electrical work is done in accordance with the requirements. It is important to work closely with the AHA throughout the design, installation, and maintenance of the electrical system. They can provide valuable guidance and help ensure that the system is safe and compliant. In addition to the technical aspects of electrical installations in Class 1 Division 1 locations, it is also important to consider the human factors. Human error is a major cause of accidents in hazardous locations. It is therefore essential to implement procedures to minimize the risk of human error. This includes providing clear and concise instructions, using checklists, and conducting regular training and drills. It is also important to foster a safety culture in which employees are encouraged to report hazards and to take responsibility for their own safety and the safety of others. By addressing both the technical and human factors, it is possible to create a safer working environment in Class 1 Division 1 locations. This will help to prevent accidents, protect personnel, and minimize the risk of property damage. The importance of proper grounding and bonding in Class 1 Division 1 locations cannot be overstated. Grounding and bonding are essential for preventing the buildup of static electricity, which can be a source of ignition in flammable atmospheres. Grounding provides a path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. Bonding connects all metal parts of the electrical system together, creating a lower impedance path for fault current to flow. The NEC provides specific requirements for grounding and bonding in Class 1 Division 1 locations. These requirements are designed to ensure that the grounding and bonding system is effective in preventing the buildup of static electricity and in providing a safe path for fault current to flow. Regular testing of the grounding and bonding system is essential to ensure that it is functioning properly. Testing should be conducted by qualified personnel using appropriate equipment. Any deficiencies should be corrected immediately. Static electricity can be generated by a variety of sources in Class 1 Division 1 locations, including the flow of liquids or gases through pipes, the movement of machinery, and the presence of personnel. It is important to take steps to minimize the generation of static electricity. This can include using conductive materials, grounding equipment, and controlling the humidity level. In addition to grounding and bonding, other measures can be taken to prevent explosions and fires in Class 1 Division 1 locations. These include using intrinsically safe equipment, providing adequate ventilation, and implementing a hot work permit system. Intrinsically safe equipment is designed to limit the amount of energy available to ignite a flammable atmosphere. This type of equipment is often used in instrumentation and control circuits. Adequate ventilation helps to prevent the buildup of flammable vapors or gases. Ventilation systems should be designed to provide a sufficient flow of air to dilute any flammable materials to below their lower explosive limit, or LEL. A hot work permit system is a procedure for controlling activities that could potentially create a source of ignition, such as welding, cutting, and grinding. The permit system requires that a hazard assessment be conducted before any hot work is performed and that appropriate precautions be taken to prevent explosions or fires. In conclusion, working in Class 1 Division 1 locations requires a thorough understanding of the hazards involved and the precautions that must be taken to prevent accidents. Adherence to the NEC guidelines, proper installation practices, regular inspections, thorough training, and the implementation of appropriate safety measures are essential to ensure the safety of personnel and property in these hazardous environments. Remember, the prevention of explosions and fires in Class 1 Division 1 locations is a shared responsibility. Everyone who works in or around these locations has a role to play in ensuring safety. By working together and following the established procedures, it is possible to create a safe and productive working environment.